How do relays, contactors, transformers work? Today, we're going to use our meter and we're going to check all of these components and we're going to see how they work with live voltage. You're watching HVAC Tips for Technicians. This is Taddy Digest. I'm Tad. Let's get started. Before we go over this little setup and use our meter, we're going to go over each component so you know what the component's called, what it looks like, and then what it's used for. So first, we're going to go over this. This is a transformer. You have step-down transformers, step-up transformers. Typically, we use step-down transformers in the HVAC field, and usually it's 115 to 24 volt, or it's 240 volt to 24 volts. So we've got a primary side where we have our primary voltage, which is a high voltage, and then we have a secondary side, which is a low voltage, which is a control voltage. And you can see some transformers that are higher in voltage, more than 240, like 480, and then 240 for the step down voltage. That's with your commercial units. So that's the first component. Second is a contactor. So this is typically used to power a compressor or a fan motor. Then we've got a sequencer. This usually has a delay. You see these in electric furnaces, maybe part of a heater kit, and this is used to power a fan motor or a heating element. Then we've got a fan relay. This is a little simple relay, usually to control a fan motor. You see these in different residential systems. We've got a switching relay. And typically, you'll see this used to control a blower motor. So you've got coil, you got normally closed and normally open contacts, which we're going to go over that. Then I've got a little board here, and this board is a blower control board. Usually these are time delay boards, so they've got a little time delay. We've went over most of the components we're going to be using. Now let's go ahead and go over the setup. All right, let me explain my setup, and then we're going to go through and we're going to check every single relay. I'm going to show you how it works and checking everything with your meters. So the first thing I have on the table is I have a thermostat, right? And we've got the Y, the G, the C, the W, and the R, right? R and C is 24 volt. G is the call for fan typically. Y is the call for cooling. And W is the call for heating, right? I've got those hooked up. I'm going to place my thermostat over the back plate. I've also got a transformer here, which is 115 volt to 24 volt. This is a step-down transformer. I've got a contactor right here, which is the first type of relay that we're going to be using to power our 115 volt fan motor. And I've got power going to this contactor right on the line side. So first thing we're going to do, plug it in. Boop. Now, we're going to take our meter and put it on volts AC or volts, like that. See the little line that's wavy? We're not checking direct current, we're checking AC power. I'm going to take my meter and we're going to check. I'm going to go ahead and turn my thermostat, set the date. All right, we're good. Make sure that it's off. All right, we're going to check the power coming into our contactor, right? Right here, where the black and white come in, that's 115 volt, or it should be. See, it says 123. All right, now, we're not going to have any voltage on the outgoing side or the load side of this contactor, right? There's no voltage. There's only voltage whenever this plunger pulls in. Right? And when it pulls in, see if I push it in, our fan motor is going to be sent power, right? Watch. See, fan motor's running. And then if I check voltage, now, since I got this pushed in, watch, well, let me just set my meter down. I'll push it in and I'll show you on the load side. There's 120, right? Now, what pulls this in is the coil getting voltage, and the coil is right here. See where the blue and the yellow wire are? Right here. If I check the coil doesn't have voltage. See my meter? 0, okay? When this has voltage, this will pull in, and then we'll have 230 over here. All right, now to make this pull in, we've got to give a call to this coil. How do we do that? Well, you can see my thermostat wires. Where does this wire go, this blue wire? It goes to the transformer's common, one side of the 24 volts. See, we've got the common going to the thermostat. And then the yellow, which is the other side, goes to my yellow wire. It goes to my Y terminal on my thermostat. So between C and Y, we need a call, right? Whenever we give the thermostat a call, it provides 24 volts to that yellow wire. And then that will give 24 volts to our coil of our contactor. So we're going to do that real quick. I'm going to push mode until it says cooling. And then it should say cool. And that's going to send 24 volts. Now, let's check at the coil and see what we got. Blue to yellow. Here's our coil. What do we got? 28 volt. That means we got power to our motor. Now, if you don't know anything about wiring motors, I've got a video, and I'll put the link in the description so you can learn more. But on the load side of the contactor, we should have 120 volts. 120 volts, see that? Now, just so you know, right here on your transformer, because we need to learn how to check it, our primary side right here, common to 115, has got 120. Okay, check out the meter, 120. And then if you check the secondary side right here, common 24, we've got our 28 volts. So we're providing the thermostat with control voltage via the transformer, okay? Without the transformer, the thermostat would have no display, okay, unless we had batteries to power it. All right, without the 120 volts coming into the contactor, there's no way we can have 120 volts on the other side of the contactor. So that is a basic overview so far. If you want to learn more about wiring on motors, remember, I've got that video down in the description. So now you know the 24 volts is what pulls in the contacts of the contactor, and it's what makes the contactor have voltage on not just the incoming side, but now the outgoing side. Hope that makes sense. We're able to run our fan motor with the contactor closing. Now you know how a contactor works. Let's go to a switching relay. I want to show you one more check using the meter for this contactor before we move forward on to that switching relay. So I'm going to take my meter dial, I'm going to put it on continuity right here, right? Same dial as ohms. So whenever we touch our meter leads together, it's going to beep, indicating that we have a closed circuit. So right now, if I check from one side of the contactor to the other, it doesn't beep, right? You can see the meter, it says OL. But whenever I hit fan on, because we've wired it now to the G terminal, the contactor pulls in and we completed the circuit. Just want to show you. Let's move forward. Now, before we hook up the fan motor and we use this relay to actually send power to that fan motor with the closing of the relay, whenever it's energized, right? The coil receives that call, that 24 volts. I want to show you what happens to each of the contacts. We got normally closed, normally open, before we have power and then when we have power, right? So take our dial, we put it on the continuity symbol, right? Looks like little waves there. And you can see, well, it'd be hard for you to see, but from 1 to 3, which is from this spade to this spade, it's normally open. So watch, if I put my meter between the two, it's going to read OL, okay? But then it says from 1 to 2, it's normally closed. So right here, complete circuit, all right? So the reason I show you that, and I'll show you the next one. The next one is from 4 to 5, it's normally open. So there's nothing, right? It's OL. But then from 4 to, I can't even read that. Okay, I think this is 4 to 6, yeah. And then 4 to 5, it's normally closed. So completed circuit. So now you can see from 4 to 5, it's closed. 1 to 2, it's closed. But from 4 to 6, it's open. And 1 to 3, it's open. Whenever we receive voltage here, which we don't have it now because we don't have a call, then 4 to 5 will open. 1 to 2 will open, but 1 to 3 will close. 4 to 6 will close, all right? So I'm going to show you that. I've got the green wire now hooked to one side of the coil. This is the coil, okay? If I take these wires off, I should have showed you that with the contactor. Whenever I take these wires off, if I put my meter to ohms, I go up here to where the upside down U, okay, and I go to the coil, you see the reading I get? 16 ohms. That's a good coil. Contactor is the same. Watch. Checking the coil of the contactor. 10. That's a good reading. Now, if you have a burnt coil, you're going to see it. It's going to be black. You know, typically a short will cause that. And then the reading is going to be off. It's going to be like 1 or 2 or 0. Something crazy like that. Just want you to know that. But you can see we have a good coil. You can tell because of the nice copper. It's not burnt. Now we've got disconnected. I'm going to go ahead and give it a call. You're going to hear it click. Okay? We're going to put our meter here. 1 to 3. See how it's not closed? Oh, what happened? It closed. So you can see we've got voltage now. But 1 to 2 was closed. But look, now it's not. 4 to 5 was closed. Now it's not. But 4 to 6 is. Look. See, it's closed. Now watch this. I'm going to leave it there on 4 to 5. I'm going to turn my fan off on the thermostat. Watch what happens. Here we go. 4 to 6. Oh, 4 to 6. I hope I didn't say 4 to 5. So 4 to 6, look. Look at there. It opened up. Because it's normally open. Stays normally open. Right? These are normally closed now. All right? But if I push fan on again, and it clicks, these normally closed relays are going to, or normally closed contacts are going to open. See? Opened. Open. But now these are closed. All right, now here's what we're going to do. We're going to wire up our fan motor. So I'm going to wire up. I got to have hot coming in. All right. So you can see for our fan motor, we've got one side of the line going to one side of our power. All right. The other side of the power is going to come from this side of the transformer. Be very careful when you're touching wires when they're hot. Got to be careful. We're going to go into this normally open relay. Boop. All right, I'm going to use this speed for the other side. All right, now, if I check, here's another way to check. We're going to go to volts AC. All right, and I'm going to go to, let's see, this side and then this side. Together, we got 120, right? Look at that. 120. But this is a normally open relay, so if we go to the other side, what do we got? 0. All right? Because the power hasn't went through yet. Now, if I take this same wire and I go, and if I don't use 1 to 3, but I use 1 to 2, watch what happens. Motor kicks on. And then if I check with my meter, again, from here to here, I got voltage, right? And then if I go to here, look. So we got voltage going all the way through. See? See how I did that? We got voltage going all the way through. Why? Because we have a normally closed contact. Put it back on. Now watch what happens when I turn the fan to on and I send 24 volts to this coil. We sent voltage to the coil, the normally closed contact, has now opened. And when it's open, you can see the voltage, right? 120. And that's another thing you need to know. If I take and I open that, I'm sorry, it's open now. Now I'm going to close it again. Look, 0. Knowing how to check the relay, there's several ways to check, right, using your meter. So knowing all those ways is going to help you in the field. So I want to show you that. Now, we're going to go take this wire. We're going to put it on the normally open. When we put it on the normally open, we can read the voltage. All right? We can read the voltage. Now, we're going to turn fan on, send 24 volts to the coil again. Our normally open relay is going to close. There's 28 volts. And then if we check, 0 voltage, right? Because it's closed. We've completed the circuit. I know that may be a lot. Rewatch the video, break it down. It's super simple. Remember, voltage is coming in here. We got 120 volts. One side of the line's going to our fan motor. The other side is going to a relay. And then on the other side of that contact, normally open contact, is a speed wire for our fan. So whenever the relay, the coil sent voltage, energizes, closes the contacts, sends that other side of the line to that fan motor. This is how to check a switching relay. Let's move forward. Next, we've got a sequencer, typically used in mobile homes, electric furnaces, to control a blower, to control a heating element. All right, let's go ahead and get our meter. We just got the coil hooked up. So we've got a white wire going to W on the thermostat. Typically, these are used for heating. And then we've got a common wire going to the common of the transformer. So we're providing the 24 volts whenever the thermostat calls for heat. Let's go ahead and check right now with our meter continuity. What do we got? So we got some contacts on top, and this is a single sequencer. Sometimes there's 2 sequencers or double sequencers. So there's a set of contacts right here, and you can see it's OL. And then we've got, and that means it's an open circuit, open loop. And then on top, we've got another set of contacts, and it is normally open as well. So open circuit, normally open, normally open, normally open, normally open. When we get a call, which we have to put it on volts AC and not continuity, when we get a call, right, those contacts are going to close. Right now we have no voltage. So we go to our thermostat, we put it on heat, boop, turn the temp up, and hopefully there's no delay, but we're going to be able to see that we have voltage here. Oh, we got voltage. See that? 29 volts. Let's go back to continuity. Check contacts. Contacts are still open. Well, could it be bad? No, it's not, because it's got a delay. You see? And you can actually see what the delay is on it usually. This one says C3060 H145. So if you know how to read that, you'll know whether it's 30 seconds, 60 seconds, 90 seconds, 45 seconds. Each sequencer is different. It's going to close in just a minute. There it goes. So it just closed. Now we're in good shape. We're reading closed circuit, so continuity. Now, did both of them close? I didn't check. Let me see. Did both of them close? Let's check the one down here. Yep, this one closed. Okay, and then this one closed. All right, now, what are we going to do? We're going to turn it off so that it opens. And we're going to hook up our fan motor so you can see. So it's still, okay, there it goes, it clicked. So it's still got a delay. Look at that. Still got a delay to even open. So why would this sequencer, why would this relay have a delay? Well, if it's in a mobile home and it's using a heater kit, then if you're, you might want your fan motor to kick on before your heater kit kicks on. What happens if your heater kit kicks on before your fan? You got a limit switch, it's probably going to overheat. It's going to open the circuit. So having this delay, having the heater kit kick on after the fan motor is already started, that's a good idea. And that's the reason that usually you have a relay that looks like this that controls the fan, and then you have a sequencer that controls the heater kit. But sometimes the sequencer controls the fan and heating as well. That way it kicks the fan on when it kicks the heater on. So now, of course, we checked. It's open. Now we're going to go ahead and hook up our fan motor. So let's hook up the high speed. Where's our high speed at? Here's our, now, you know what? Let's hook up our low speed. Let's not get too wild. So low speed on one side. And then we got to have our power coming in, of course. So hooking up to one side of our transformer. Careful not too touchy. Now, if we check volts AC and we measure across the circuit, got 120 volts, right? 120 volts. Okay, if we check from here to our other side of our line, see the white? What do we got? Let me go back on here. It's 120. Now, if we go to the other side, look right here, instead of here, go to here. What do we got? 0. All right, 2 ways to check it, right? Check on the other side, we got 0. Circuit's not complete. But if we check across, I should have said that earlier, I should have been more specific with that. Checking across, we got 120. But there's no power going to our motor. But what's it going to read whenever it closes? It's going to read 0, right? We've completed the circuit, our fan's going to kick on. Let's go ahead and turn, and just to verify, we don't have voltage at our coil. No voltage at our coil. Look at there. Turn mode to heat because we got our white wire connected. White and blue, C and W connected to our coil. It clicked. 29 volts. Look at that, 29 volts to our coil. But is this closed? No, it's not closed. Why? Because it's got a delay. Sequencers have a delay. What's going to happen though? Once it finally closes, we're not going to read 124, we're going to read 0. From white to this side, we're going to read 124. Look, fan motor's running. We're reading what? 0, right? We completed the circuit. And now, if we read from this side to white, we have the same thing we had earlier, which is 124. And then if we go to the other side, what do we got? Boop. 124. All right. Now you know how to check a sequencer. Next, we have a typical fan relay. And you can actually see there's a little diagram right here, but it's kind of hard to understand. But if you look, you can see that these 3 spades look different than these 2. So between 1 and 3, we have our coil. This is where we get our 24-volt call. Between 4 and 5, we have a normally closed contact. Between 4 and 2, we have normally open. So whenever we get voltage here, 4 and 5 will open and 2 and 4 will close. I've got the coil wires connected between 1 and 3. And right now, of course, we don't have a call. So we don't have any voltage here. Between 2 and 4, we don't read anything. This is a normally open set of contacts. Between 4 and 5, we read continuity because it's closed. It's a normally closed set of contacts. But this 4 and 5 should open and 4 and 2 should close whenever we do receive 24 volts. So let's put our meter on volts AC and let's go ahead and measure between 1 and 3. We've got 0. Let's go ahead and turn our thermostat to fan on. Oh, wrong button. Fan on. We'll receive voltage here, but let's go ahead and measure between 4 and 5. Continuity. Oh, look at that. Opens the circuit. And this was closed, normally closed. Now it's open. 4 and 2 was open, and now it's closed. Now let's go back to volts, and let's measure between 1 and 3. Why did it close? Why did it open? Because, well, we received voltage. 29 volts. Now, let's go ahead and turn this back off. We'll hear a click, and let's connect our wires for our fan motor. So this was normally, let's see, which one do we want to connect? Go back to continuity. This is already normally closed. So if we connect our fan motor here, it's going to kick on. We're going to go between 4 and 2. All right, so we got to get our power coming in first. One side of the line. And then we'll use our low speed for our motor. If we connect it here, watch. Fan motor kicks on, right? Normally closed. Let's go to the normally open contact. It doesn't kick on. Now, if we check volts AC, let's do this again. Here we go. Between 2 and 4, 123 volts, right? Now let's turn the fan to on. 123 volts. Relay is going to click. Voltage goes away, 0. Why? Because we completed the circuit. And we have voltage. How do we know we have voltage? Check the coil. Let's check the coil real quick here. And there it is. All right, now what is another check we can make? We can go from the other side, the white, and we can go to here, right? And we got 123. And then we follow that wire and we go to the relay here. We got 123. Then we go to the other side of the relay. And we got 123. So the voltage is going all the way to the motor. All right, but if we take and turn it off, go back to this white, and then go to that side of the relay, what happens when we don't have a call? See, power's not going through that relay to that fan motor. That's how you check the fan relay. Now let's test the blower control board or the blower time delay relay board. Now this board's a little bit different than a typical relay because it needs the secondary voltage from the transformer. It doesn't just need C and Y or C and G or C and W. It needs C and R and then Y or G or W. Now we're going to use C and G for this, but I wanted you to know that we also hooked up the R from the secondary of the transformer. So here's the board, and you can see here's the relay portion, right? Now you can see I've got the red hooked up to this terminal, and it actually says XFMR, which is, transformer. It stands for transformer, XFMR. And then we've got our call coming here. This is G. You can see it goes to the G thermostat wire. And then I've got my blue, okay? And this is just C, and this is the same thing, really. But it has to have this and this to actually power the board. Now, for the relay portion, right now we don't have a call, okay? How do we know that? If we go from G to C, you can see on our meter, let's put it on volts AC and go from C to G. 0, right? So we don't have a call. So let's look at what types of contacts we have. So from here to here, oh, we got to go to continuity. From here to here, we've got a normally closed contact. And then from here to here, we've got a normally open contact. All right, so that means if we take and go ahead and give a call to the board, go to this normally closed contact. Oh, heard thermostat click. Should have a little bit of a delay though, and it does. Oh, there it goes. Now this normally closed is normally open, or it's not normally open, but it's open now. Normally closed, opened. And we did send voltage, right? Let's see. Do we have voltage? 29 volts. All right, so let's go ahead and turn it off. Take the call away. And then let's hook up our fan motor wires. All right, let's bring in that other side of the line from the primary side of the transformer into the relay. And then let's bring in this low speed wire to, if we put it here, it's going to kick on, right? Oh, wait, that was normally open. That's right. So be careful. Oh, looks like we got an issue with this board. See? Normally closed, it runs. Normally open, it will not unless we give it a call. Let's give it a call. And let's turn our meter to volts and check here to here. What do we got? 124. We just gave it a call, just clicked. Now the relay is going to close. We're waiting. You can do it. Got a little bit of a delay. Here we go. We got voltage, so we know it's not closed. We'll read voltage whenever it closes. We'll read 0 whenever it closes. Motor's on. The relay has closed. And look, 0 volts. All right. Now you know a bunch of different components, the names, where they're used, and how to use your meter to check all these different components, these contactors, these relays, and these boards. Hope you enjoyed this video. Hope you learned something. If you did learn something, let me know what it was in the comments. You got a question? Remember, questions can lead to new content. So put your questions down below. But if you don't have a question, that's okay. Let me know who you are. Let me know where you're from. You want more videos like this? Go check out my playlist, HVAC Tips for Technicians. I've got hundreds of videos of live experience in the field as a technician to help you be a better technician. If you like this video, hit the like button, subscribe, and smash that bell, ding, so you know what I'm doing. You've been watching HVAC Tips for Technicians. I'm Tad, this was Taddy Digest, and I'll keep you cool if you let me.